Good afternoon, everybody. Good afternoon. So my name's Matt Lorenzen. I'm going to be running this track for you this afternoon. I'm a principal consultant. I work with a company called Cypress, based in Tewkesbury in the UK. I've been taking CREST exams for about a decade, so I understand the challenges of these certifications, and I've seen the organisation change quite a lot over that time. We've got some really interesting talks outlined for this afternoon across a broad range of topics, but I'd like to introduce our first speaker. We're going to be exploring open source large language models, the implementation and the use cases for offensive security. So if you could please give Carlos Marquez a warm welcome.
Well, thank you everybody for coming. Thank you, Chris, for having me today. The goal, I have two goals on this presentation. Basically, the first one is try to make sure that everybody will be able to run large language model in their own hardware. That's hopefully something that we can achieve after this talk. And also, I would like to make sure that you get some basic bricks that can be used to build your own tools that can be used as part of the workflow in the penetration testing. So that's probably the main goals. So let's kick off. All right. My name is Carlos Marquez. I'm part of the Orion X team, which is the offensive security operation team for Agenix. And well, about AI, of course, it's not a new topic. We have been talking about that for a while now. And of course, generative AI now is the protagonist of what we are doing now, of what is trending right now. And different than AI, machine learning is also a subject that is a branch of artificial intelligence, and is focused on the use of data and algorithms to reduce the error, improve accuracy, and imitate the way how humans learn. So, first example will be based on using machine learning classification of images in an offensive security, from an offensive security intention, let's say. We are going to use AVoler, which is a tool created by the team of Bishop Fox. It's a tool that has been around for a while right now. And the tool is meant to help a pen tester that is running in a large scope and grabs several screenshots from web applications, probably with A-Witness or GoWitness or any other tool. And the idea is that the tool will be able to classify each of the screenshots using based on the information that has been used for the training. So basically, in order to run it, you just clean the repository, install Python requirements, download the parameters to run the model. So these parameters are the values that the model actually learned, like the pre-trained values that the model used to activate some logics in the neural logics of the model in order to run it. And finally, you launch the script, the Python script. So we have a short demo here that is going there. So basically, we're going to have multiple images from screenshots for web pages, authentication pages, web application, BBC, login pages, for example, for PHP, MyAdmin, or Parquet domains. And we are going to run it. We are going to call the script. The script is going to use as well the previous values of the pre-trained information that have been created before. And the output will be a CSV file that contains the probability of each of the screenshots to belong to one of the categories that have been listed before. So you can see, for example, that some applications are easily identified as a login web application. Some applications or some screenshots were listed as a Parquet domain, like that. And if we go and check the results, we can see that the machine learning model actually generates an spreadsheet with the calculation of the probability between 0 to 1 to each of the screenshots to belong to one of the categories. This information is obtained based on the trained data that was created by the authors of the tool. So that's the output of the machine learning model. Then we are going to found that this is a supervised learning, a classification method using image classification, and it's supervised because the data set that we use to train the model, or the author used to train the model, is already have some labels before. So this is supervised learning. So this is machine learning. Now, if we are going to do the same thing using open-source LLM, we can use multimodal large language model. In this case, we are going to use Lava on CPU, and we're going to use Ollama as a backend. Later on, we are going to go on the technical details, and we are going to process one of the screenshots, in this case, the PHP myadmin, and actually we are going to indicate to the prompt used to the model is actually indicate that we are going to upload a screenshot of a web page, and the task for the model is to identify if there is an authentication web page, and it identifies there is an authentication page. It should extract the name of the forms that have been identified in the screenshot. So we upload the image, and of course it takes a little bit of while because we are running right now only on CPU. I think that this was running this laptop, which is a Intel 7. Not a fancy, expensive laptop anyway. And of course, the model is able to identify the authentication forms, identify the name of the forms, and get some, I think that's a pretty useful answer at the end. If we do repeat, for example, this example, the same with the same prompt, but in this case, we are going to run it in the internet hosted demo of the authors of Llama. We are going to upload, in this case, the BBC screenshot. Hold on, please. We are going to see, okay. We're going to see that the model is able to, again, identify that this is not an authentication web page, and identify that this is a BBC, and a screenshot of the BBC website, and identify that there are no forms to be actually used to authenticate or send some information. So we can see that the large language model output differs from the machine learning models in the way how the output is generated in these cases. But however, both tools help us to build a workflow where we can classify images and get I suppose that is a decent, useful output as part of a pen test flow. So well, let's get back to this one. Right. Of course, everybody knows that what is a large language model. The large language model is a machine learning model that can predict the next token based on the information and the data that has been used to be trained. The parameters are usually the weights of the model that have been learned during the pre-trained stages, similar like the weight that we uploaded, the weights, or the file with the weights that we downloaded when we run Abe Euler. And of course, LLMs are a thing that they are very trendy because they can mimic the human speech patterns. So this is why they are accessible right now and probably very, very trendy, of course. So let's talk how we can run those devices in customer hardware, let's say, in desktop hardware. So first, I'm going to talk about Ollama, which is an implementation that enables to run locally as a different set of large language models. This is built on top of the project Llama CPP by Georgy Gerganov. And I think it's very useful because you just need to run the installer, one-line installer, and then define which model would you like to run. And in this screenshot from the GitHub webpage, you can see that the file size of the model that you can download from the internet, those models are quantized. It means that it's like reduce the resolution of the model. So of course, there is always a trade-off between the efficiency and also the quality of the responses, but it helps a lot make this quantization in order to make sure that you can run it locally in different kind of hardware. And usually this indicator also is an indicator to learn how many RAM memory you need to run these models locally. So you can see that there are very small models that you probably can run even in a mobile device, which is, I think, it's very flexible. Once you run Ollama, it starts a local API in the local host of your system, and it's an HTTP REST API. And which is very nice is that it mimics the OpenAPI structure. It means that you can reuse all the tools that have been written to use ChatGPT as a backend model using the API. You can probably run it using Ollama or probably many other tools that we are going to talk about later on, because the structure of the API is the same. So most of the time, you only need to change the URL, and you are going to power your tools using local LLM models. Right. So about multimodal large language model, we already saw LLaVA, Large Language and Vision Assistant in action. And recently, at the end of May, Microsoft just launched Pi-Vision, sorry. And I haven't tried it yet, but it looks very promising, and it's open source as well. And of course, as you can see, the multimodal large language model enabled the possibility to combine other kind of information, such as images or videos or even audio. And that's very powerful because it changed the way how we interact with the models. Probably we already saw that with GPT-4o. And of course, it may enable the possibility to actually power robotic solutions, maybe enable those devices to learn by imitation. That probably will change a lot the industry in general. So I think that's a quite interesting topic as well. And well, why we should, or we may want to use open source large language model. Probably pricing is one of the reasons. The cost is something that maybe we have to consider, but of course there are other, let's say, benefits. I think the privacy is probably one of the most important things, considering that whenever we are using a, let's say, closed source language model, we are uploading our information to a third-party cloud provider. Let's say if we are talking about a pen testing, we don't want to send our customer information to a third-party cloud. That probably breaks some non-disclosure agreements, but that's one of the main benefits of that. And the possibility to control the data flow of the information that we are using is I think, one of the benefits. Also, the possibility to run non-censored models is quite important. Of course, you can bypass the protection of a closed source model, but however, the enterprise define how the model is going to be used. However, if we use a non-censored or we make our own implementation, definitely we are going to bypass these barriers. Of course, there are hardware requirements, but as I indicated before, even a CPU, Intel, AMD works fine. If you have a GPU, also works even better. And however, we have to deal with the same challenges that other large language models or all large language models are facing. For example, the transparency, because the information generated definitely will depend on the corpus or the data that has been used to train the model initially. And of course, hallucinations or inaccurate data it's possible to come up by using large language models. It's something inherent to this technology. But also a good feature is the ability to fine-tune a model to make sure that the model is efficient and tailored for a specific business requirement that you want to implement. So I think that this offers several advantages. There is a good reference on why to use open source large language models by IBM. Actually, I think that this video is quite inspiring for identify those benefits. And the large language models have been, the open source large language models have been growing their efficiency so fast with a big pace in the last months. For example, in this image, I want to highlight, this is Hugging Face, this is the Hugging Face web page, when it has the average of the top score of multiple benchmarks of the best open source models. And what I want to highlight is how how the pace of improvement has been growing in few months in different benchmarks. So there are really powerful tools here that are available for everybody without paying or without the requirement of having a huge data center running. So I think it's a technology that definitely we may want to consider. Well, what could be the good cases to run AI or large language model? Probably if we want to automate repetitive, tedious tasks. Also, when we find problems where the input is a little bit fuzzy and one size fits all is not something that is easy to achieve, definitely a large language model can probably help us to deal with that. But however, it's resource intensive. For example, the Ollama example, the Ollama demo with one screenshot took around 10 minutes only with CPU. The good thing is there are, depending on the model, depending on the optimization that you can use, the quantization, you can eventually have a very decent results using hardware that is not that complex. And what is good as well is that some implementation can be code-free, as we saw as well in the previous demos when we don't need to code a line. However, also we need to consider that AI is expensive. There are studies that indicate that a Google search now using the rich AI-powered features is taking 10 times more electricity than it used to take before. And of course, a data center needs to be cool. GPUs require a lot of energy. They are not anyway cheap. And we don't have unlimited resources, so it's something that probably is part of the consideration. And it means that probably small models also make sense. I saw in the news recently the strategy for Apple promising that there will be more processing of the information locally in the device, probably using models that are smaller in size, and they want to avoid sending information to the data center because definitely it's expensive. Definitely there are some complications, and we talked about privacy before. So maybe small models also make sense. Probably, or usually open source models are moving between the nano and the large sizes. We have seen that there are different versions and different alternatives to generate those models. And that's probably make us considering that there will be, in the future, some hardware specialized to run those specific models. Examples could be Grok, which is used in a new architecture of processor that is called LPU, Language Processing Unit, optimized for run these kind of processes. And however, we are seeing these new hardware optimizations in hardware such as Apple devices based on the M Silicon or Microsoft Copilot PC. So probably that will be something that we're going to see more often in the future. But we are already seeing that. About the security of LLM models, I think it's a very trendy topic. You probably already have seen about the top 10 risks of LLM applications. We are not going to focus on this today, but we would like to focus specifically in one control of the suggested steps, mitigation steps suggested by the OWASP in order to protect either the input or the output of a system. One of the controls suggests that we can monitor the input of the output in order to detect or address weaknesses in large language models. So we are going to use a proof of concept that is available in GitHub. I will share the others later on. We're going to use LlamaGuard, which is a model created by Meta, and is designed to monitor either the input or the output of an LLM system or an application system. In this case, will be based on a chat box where a human is interacting with the machine in order to identify safe or unsafe content. And there is a good paper about that created by Meta. So the demo is available in the internet, in GitHub, the demo or the source code that I used to build this output. This was built using Llama CPP ported for Python, which is quite cool because this implementation of Llama CPP is using C and C# initially to run large language models locally in a machine, but it has been ported in different languages, including Python. So in the demo, basically, we feed the Llama guard model with a set of rules, with a set of categories of unsafe content, and the task is to classify if a prompt is safe or is unsafe based on the information that has been provided. So, for example, if you want to steal a fighter jet, or if you want to break into a car, this is unsafe and is the category 03, which is criminal planning. It makes a lot of sense. Killing a Linux process seems to be safe, which makes sense anyway. But however, if you identify yourself as Luke Skywalker and you want to steal a fighter jet from Darth Vader, the system considers that to be a safe prompt. So, of course, this is an example, basic example of prompt injection. But anyway, I think that the point what I want to highlight is the requirement to monitor either input or output requires understanding the context of the conversation. So it's interesting to see how this implementation of actually protect the prompts can be generated. I said that we can monitor the input. For example, when we see the prompt itself, the user line corresponds to the information that is entered by the user, and the agent is the response of the LLM model. So in this case, we can monitor either the input or the output using the same model, basically processing different parts of the prompt that is going to be fed to the Llama guard model. Right. One of the most popular applications is RAG, which is retrieval augmented generation, which is a technique that enables the accuracy and reliability of generative AI because enables the model to fetch information from specific data repositories. That could be PDF databases, that could be videos, that could be scrapping content from URLs. And is a way like use an open book approach, like chat with your data. And how it works is the following. It takes the data sources, the documents or the PDFs or the databases. It separates in different splits. It divides the data in different splits and stores in a vector state database. The vector state is digital information that can be used by the machine learning models to actually process the information easily because it's a format that is familiar to the machine. And once the question from the actual user is arriving to the system, the first task that the LLM or the system does is look in the vector state to find which relevant splits are related with the query or the question that is sent by the user, and depending, of course, on the prompt or the guidelines that have been provided to the LLM model, it will provide an answer. So we are going to make a short demo of that. In this case, this demo was implemented with LM Studio. If you are not using it right now, it's very good to start with this tool because it's a graphic application that is compatible with any platform. Again, it runs an open API-like API, local API running over HTTP. And it is, if the drivers are properly installed in a system, it can detect all GPUs, either Intel, AMD, or CUDA driver for NVIDIA GPUs. So I think it's really, really flexible. And the parameterization is so easy because you can tweak how the model is loaded in the memory, into the virtual RAM of the system, or even in the RAM of your laptop or your computer if you want to. So the demo is, again, available in a GitHub repository, in a public GitHub repository. And for this demo, we are going to perform a RAG from the PDF of the OWASP top 10 LLM risks. I'm using the local model, the local LLM model, Orca 2, 13 billion from Microsoft. I think that probably 13 billion is the minimum size that I found that works with decent results with in order to perform these specific RAG queries. So, So let's go for the demo. So in this case, I'm using PowerCharm as a backend, and I apologize with everybody because I only focus on the code. There are a lot of GUIs that can be run to make it look beautiful, but I think that important is to learn the concept of the backend, and later on you can find the way to do it. So actually, what we are doing here is asking what is the definition of over-reliance based on the PDF document of the OWASP top 10 risks for LLMs. So I'm using also LangSmith, which is a module of LangChain that enables you to debug the queries that you are sending to a large language model. So for example, in this case, you can see that there are two queries related with this question. The first query is going to identify which chunks of the PDF actually contain information related with the question that we sent. What is the definition of over-reliance? And the second query is taking all the chunks together and builds a proper answer to the question. So you can see that, for example, we can see the number of tokens that we are using, and probably at some point we are going to see ChatGPT somewhere, because the API that is used by LM Studio also match with the OpenAPI structure of the API. So this is why it works like that. So we can see here that there are multiple chunks, in this case 2 chunks that have information related with the initial questions, and this is how it works in the backend. So this Smith LangChain is a very useful tool to develop your own tools and actually debug and identify what is happening in the backend. So, okay. And as in any other supply chain, in any other software-based system, supply chain and integrity is absolutely critical. And for example, if we, in this case, we are seeing the same implementation. I'm just asking about what is the password, and in this case, the source document that has been used for the RAG has been polluted by myself using hiding a password somewhere. So we can see that the password was gathered from the LLM. And finally, if we go probably to the end of the video, we can see that. We can see that the RAG operation was performed, and at the end I hid some specific information in the PDF. So again, that will be a way to do, for example, prompt injection, as we saw in the presentation in the morning. So it's simply an example about how integrity could be critical with these specific implementations. Right. Back in February, I found an interesting blog about how machine learning models have been used to target data scientists using backdoored information. So usually, you know that any information, any data that contains, any file that contains binary data can be eventually weaponized, because at the end, this data or this binary instruction is going to be executed. And machine learning models are a perfect example to do it. For example, the weights that we used to run A-Bowler at the beginning were stored in H5 format. So I think that was cool to see or to reproduce this attack using an open source large language model. So in this case, this demo is going to run again locally. We are going to use LM Studio. In this case, we are not going to use the API. We are going to use a fine-tuned version, and we are going to use the chat interface that is pretty similar to the experience that you have chatting with ChatGPT or any other vendor. And in this case, I'm using White Rabbit Neo, which is a fine-tuned LLM that is specific, trained on information security, either offensive or defensive cybersecurity. This is built by the White Rabbit team, White Rabbit Neo team as well. And there are different versions for this one. In this case, for the demo, I'm going to use White Rabbit Neo, the 33 billion parameters. And in the demo, what we are going to do is reproduce the attack that we presented in the blog before. So first, what I'm doing is asking to the large language model to generate a code to use the Python library to serialize a reverse shell using Python 3 and IPv4, and my target will be a Linux machine. Of course, I'm provided the attacker IP and port in order to receive the reverse shell. So the first step of the code was actually generate how to generate the file that mimics the model. Of course, and then we are going to start the attacker machine. Our victim machine will be the Kali Linux. So this is the IP address. And I'm going to copy and paste the Python code that was generated by the model directly. So the output of this code will be a pickle, like a pickle formatted code that contains the line that includes the reverse shell. So I generated the code, and the file will be named pytorch.model. So we can see that the file has been created and it's a data file. So now we have first of the step, we have our payload, and now the second question that I'm sending to the White Rabbit Neo LLM is write a Python script to deserialize the information contained in this file. And again, I'm going to receive the output of the Python output, the Python piece of code that I should run in order to deserialize the instructions that were stored in the previous system. So since the Kali Linux is the victim, I'm pasting the same code that was generated by the LLM system. And finally, when the process is called and the reverse shell is run, we are going to receive the connection back. And of course, this is a reverse shell created 100% by the fine-tuned LLM model locally, which I think is cool because I didn't pay for running the LLM, as everything was run locally using the community LLM model. So I think it's a very nice application, and kudos for the guys who are actually creating these kind of tools. Right. Finally, I'm going to talk about AI agents. Agents, I think, that probably is a very powerful tool. Before, we have been talking about agents because an agent is a piece of software that can interact with the environment. So now we can take an agent powered by an LLM, could be either a closed source or an open source LLM, it doesn't matter, and we can enable this agent to interact and use roles or use tools and operate together in a cohesive unit. So for example, you can set a goal to the whole system and multiple tasks will be achieved in order to make sure that this goal is reached. So the possibility to create complex workflow, and more important, the possibility to enable a model to interact the tools that are created by yourself offers a wide range of possibility to create powerful workflows. There are very good frameworks around to create this kind of agents implementations. The most popular probably have been QAI or AutoGen, which is from Microsoft. Actually, they launched months ago Autogen Studio, which is a GUI that you can use to create the whole structure of agents without code. Also, LangChain agent supports the implementation of this kind of workflow, so it's definitely good to check it. There is a presentation, a short presentation, 10-minute presentation of Andrew Ng from Stanford University that presented on Sequoia Capital about what is an AI agent. It's good to deeply understand what is happening there. I think I like it a lot, and I like how he explained what could be the use of these specific workflows. And again, considering that we can run agents in multiple software or in multiple hardware that is reachable, probably this can run without required cloud and expensive systems to be executed. An example that I'm taking from Autogen is a workflow when there's user agent proxy, so it's an agent that interacts with the user, and in this case, the user asks to the system to plot a chart of a business stock market. So one agent is going to create the code to bring the information from the internet, the specific information that is required, and then identify which information is missing or which package is missing. Also, probably another agent is going to actually execute the code that has been created for the first agent. What is good is they can iterate in order to correct and self-correct the output of the previous agent, which reduces a lot or improves the quality of the output. And finally, the question that was generated at the beginning by the human is generated. So I think it's a very, very powerful example. And the application of this kind of workflows is really wide. So the next demo is not a video, because the video could take ages because it's a heavy process. In the demo, anyway, the source code used is again available in GitHub. A penetration testing assistant was created. In this case, I was using CrewAI and multiple LLMs in order to execute a workflow that basically is going to take the output of a security tool. In this case, I am using an nmat output as a tool. I'm using the .nmat file, the text file, because this is what the LLM actually understand. They may eventually understand the XML as well, but probably that will be. I think that the strength of the LLMs is dealing with text, so definitely that make them easy to run. What we are going to do, the first agent is going to extract the relevant information of the input, the port, the host name, the software, or the version that is running there, the CPE, the banner. And I'm going to have multiple agents that have access to different tools. The first agent is White Rabbit Neo. In this case, I'm using the 8 billion version of White Rabbit Neo. It's running locally, again, with LM Studio. This is a fine-tuned version of Llama 3, focus on offensive, defensive cybersecurity operations. Another agent is going to be an internet search agent. It's going to use a tool. In this case, I'm using an API that is called serper.dev that is able to look. In this case, I'm using bookhatrix.xyz, which created by Carlos Polop. It's a very good resource of pentesting, of course. I'm pretty sure that you have used it eventually. And the idea is that the first agent is going to ask to the large language model, okay, what attack vectors can you suggest given this system? Then also I'm going to perform a search similar to the retrieved augmented generation in order to identify attack vectors, but in this case, tailored for this specific data source. And finally, I'm going to use a third agent to gather information from Wikipedia about the protocol or maybe the vendor. It definitely depends on the input that we have here. The input will be fuzzy. And at the end, I'm telling to the last agent is going to be Llama. Actually, I'm running this one in Grok, which is quite efficient. It's a really fast provider. Is going to take all the information together and generate a markup report, with common examples and references. So when I run this system or this, for example, using an SSH input, I was able to get, of course, the information of the background initially, probably gathered from Wikipedia, and it can be used well, to identify information from the target that was provided, and it suggests some attacks, some tools, some attack vectors that can be used. It suggests what tools I think either the model of the web page are suggesting as a potential attack vectors, and the impact of integrity, availability, or confidentiality that at the end was not that brilliant because it's pretty obvious. But anyway, everything was created automatically by the agents. If I run again this one using a light HTTP input, again, the output was focused on identify, for example, information related with exploitation of light HTTP, CGI in this case, or gather more information about the banner, for example, using Nmap. So, and also suggest a specific meta-exploit model that can be used. And what I like is part of the prompting indicate that it should provide the source of the information that it's using. So at the end it could be, this is probably a proof of concept yet, but anyway, if we consider this workflow and later on add a next agent able to actually execute whatever vectors have been suggested and probably created, that will be a powerful tool. So I wanted to close with this one because we are using probably more all the tools all together. We are using RAG. We are using also fine-tuned LLMs, and of course we are running it locally using LM Studio, and also we are using third-party providers with a specific architecture to make it efficient. I just want to clarify that I'm not affiliated with any of the vendors that I'm naming here, but it's good to say it anyway. But I think there are simply good tools that are available for the public. So thank you for joining today. I think that AI is definitely a very nice tool, and I just find this picture that is amazing in London, you know. But I think that probably this may be bricks that may enable you to build your own tools and integrate AI workflows into your pen testing day-to-day activities, and I think that could be nice, and particularly doing in your own hardware. That's what I want to have today. Thank you so much.